Hi there, welcome to Evidently YouTube channel. My name is Emily, I am CTO of Evidently, and today we are going to have a tutorial on how you can evaluate your large language models based applications with help of Evidently. I will start from the fact that Evidently is an open source Python package, so in order to use it, you would need to install it. I personally prefer to work locally, so I already created my virtual environment and installed Evidently on my laptop. You can totally do the same, or if you prefer to work in Google Colab, you can totally do it here. Here is a command for you. If you do it from Google, please do not forget to run pip install Evidently, and you will need to add LLM extension because we are going to work with large language models. So here we go. I will also need to import a couple of standard packages like pandas, numpy or requests. You will need them to work with our toy dataset. So let me import it. And also I'm going to import a couple of things from Evidently, such as report, test suite, some metrics and tests, and I'm definitely going to comment on them later when we use it. Here we go, and also Evidently has a very nice cloud where you can load the results of your evaluations and build very nice visual dashboards. You can also build the monitoring and time and share the results with your teammates. So I'm going to show how you can do that. And to be able to connect from my Jupyter notebook to the cloud, I will need to create cloud workspace. So I import this as well. Evidently has very nice UI where you can build very beautiful and informative dashboards. You can totally do it with help of UI, but I personally prefer to customize my dashboard with help of Python. This is why I import quite a lot of things from Evidently UI dashboards. Let me do that, and now we have everything to get started. In order to play around with some application, we prepared some toy dataset. It's already loaded to Evidently GitHub, so in order to get it, we would need to load it from the GitHub. Here is the command. We use request here, and well, now we loaded this CSV data and we can build up our pandas data frame from this data. I would also parse the dates so that we have the right format. And let us see how our data frame looks like. I know that there are quite a lot of long text in our pandas data frame. This is why I would set option display max column width so that we can read through all the texts. And that's the preview of our data, so that we can see the index, which is date time, the question user asks from our virtual assistant, like how do I request medical leave through the employee portal? Nice question, actually. Here is a response from our virtual assistant, and we also have some metadata like start time, end time, organization, model ID, region, environment, and feedback if it was provided by a user. So here is the structure of our data, which makes sense for virtual assistants. And now let's set up our workspace. As I told you before, Evidently has very nice cloud where you can build a dashboard. In order to be able to send your evaluation results to the cloud, you would need to first sign up and then connect through your work environment to the cloud. In order to create your account, please visit evidently.cloud, sign up, here is a link, and I already have an account. In order to configure my cloud workspace, I need to create cloud workspace object, here it is, and specify token and URL. URL is the follow app.evidently.cloud. Here it is. You can see that I already signed up and I have quite a lot of projects. So in order to send my data from the Jupyter notebook to Evidently Cloud, I would need to use token. Here is the tab where I can access it. Then please hit generate token. It will give you a token and then just copy it and paste in your working environment. Here is my token, at least half of it. So let me create cloud workspace. And now there are two ways how I can get started with the project. I prefer to do it from the Python so that I can then run the whole workflow from the single place. Here is how I create the project. I just specify the name and the team ID. And this is pretty interesting. Let me show you what it is. In Evidently, you can organize your work with a team. In order to do that, you can access Teams tab and create team, or maybe access already created team to see the team ID. For instance, if I hit my personal team, here is the team ID which I can copy and then specify it in my project. It will help me to make sure that project is located under the specific team and all team members who I invited to the team before or who I will invite later will have an access to my project. So here is the teams. I think I will choose something from here. Yeah, actually I already chosen. And here is the place where you can specify your team ID in case you build your project from the code. And as I mentioned before, you can totally do everything from the UI. So here is a button to create new project. First, please specify an organization. I would go for my personal one. Then you can select a team like personal and specify the name of your project and description. But as I told you before, I prefer to do it from the Python environment. So here it is. I create my project. Here you can write some project description and do not forget to save the configurations of your project. Yep. We can see that it's all successfully created. Here is an ID of your project, the name, description, and some details about panels, tabs, and additional information. If I now go back to my Evidently Cloud, and let me just update it, here is my project, right? We just created it. There is no data, no dashboard, but we already have a placeholder where we can start load our evaluation results. But okay, we have a place to load our results. Now let's focus more on the evaluations. First of all, we will need to parse our data, right? Because we need to work with this dataset. And Evidently can parse the data automatically. But to make sure that Evidently parsed all the data correctly, because in order to do it automatically, Evidently just take into account the types of the columns, you can tell Evidently how to parse your data specifically. Like where is the datetime index? Where are datetime features? Maybe some text features or categorical ones. Here is my column mapping. So I would say that my datetime index is start time because I prefer to have my data indexed by start time. Also, I have two text features, question and response, and quite a lot of categorical features like organization, model ID, region, environment, and feedback. So column mapping is created, and later I'm going to reuse this mapping in all my evaluations so that I know that every time I parse the data and calculate something, the data parsed correctly. We will start from some basic example. In order to create the report, we will need to create report object, here it is, and then we will need to tell Evidently what metrics you would like to include in your report. We work with the LLM-based application Virtual Assistant, so it makes sense to use text evaluation preset. Here it is, and here just specify the name of the column you want to analyze. We have two text columns, response, question. Let's start from the response. And you can calculate some descriptors, which is basically statistics calculated on top of the raw text data. It can be very interesting or very straightforward statistics. Let us start from the very basic example and calculate text length. So for every single text in the column response, Evidently will calculate text length for you, and then it will build a report with the statistics accumulated and aggregated the whole pandas data frame and this column. So let's do that. That's how we specified the report. Now let's use method run, and in this method you can pass a single data frame or two. Let us start from the single data frame. For the purpose of the example, I will take only 100 of first rows in my data frame. Here is our column mapping, and basically that's it. Let's run a report. Yep. You can see that it's very, very fast, right? So here is the statistics. For our response, you can see that there is the number of rows. We specifically selected only 100, some mean value, mean text length, standard deviation, and other statistics. And also you have the visualization of the distribution for the text length over the response column. Also, you can open up the details and see the text length measured in time. If there are some interesting patterns, you will be able to see that. For instance, maybe in the morning, the responses are for some reason longer than in the evening. Who knows, right? Yeah. As I mentioned before, you can totally pass two data frames to evidently report if you want to do some side-by-side comparison. Let us try to do that. We will keep the same report, so you can see that all configurations are the same, but now to reference data instead of none, I would pass some logs. So it would be assistant logs from 0 to 50. So it will be first 50 rows, and the next 50 rows would go to the current dataset. It specifically makes sense if you have some reference data where you are happy with the result of your assistance, with the responses, and you can use those data as the basis for your comparison, right? In this case, use your reference data here and pass it as the reference data to run your evaluations. So let us run it, and now you can see that we actually have two columns of statistics. First for current data, current batch of data, and then for our reference. And you can compare it. For instance, you can see that the mean of our text lengths become longer for some reason, and you can totally compare all the rest statistics. Here is the visualization, linear scale and log scale if you are more interested in that. And of course, there is the data in time. Yep. Now let's move to the text patterns and see more interesting or more complex descriptors. If you have some patterns in mind which you can test your text against, you can do it with help of descriptor include words, for example. And please follow our documentation, because together with include text example we have so many more. We have contains, begins with, and with, regaps. So play around with that, it's very, very interesting. I would do the following. I will take include words examples so that I can check whether users often mention some compensation, right? In order to check it, I would like to see whether the user response include words like salary, benefits, or payroll. Let me do this. And I'm going to check it only on my current data, which is first 100 rows of the logs. So here it is, and now you can see how evidently builds the report for categorical statistics. Now we can see the binary result, false or true, whether those words were mentioned or not actually, and we can see that 10 times those words were mentioned and like 90 times no, right? And here is some details, so that you can track the shares of mention of some compensation in time. Okay, now let's move on to a little bit more complex scoring. Together with some straightforward statistics, you can use something more complex. For instance, in Evidently, we have some built-in machine learning models, like a model for sentiment analysis, which can return your score for the sentiment in the text. Let's see how we can do that. Again, I'm using the report. In metrics, I use text evaluations, but now instead of include words descriptor, I use sentiment. I will use it without any arguments because it's built-in Evidently model. So let me just run the same syntax but with sentiment descriptor, and you can see the statistics for sentiment. So again, you can see that the mean sentiment is equal to 0.6, so it's positive mostly, and here is the distribution. For your convenience, we have some pre-selected models, like model for Toxicity, and also if you have in mind some specific model, for instance the model to detect the emotions of the text, you can pass this model and tell Evidently explicitly how to parse the response of this model. So let us now build a report which includes two different descriptors. First is Toxicity model pre-selected by Evidently. This descriptor is called Hugging Face Toxicity model. Here it is. And also let's specify the model manually. So we went through the models and selected this Roberta-based emotions model. And in order to call it from Evidently, I just create Hugging Face model descriptor. Then I specify the name of my model, right? Some params, and I would like to check whether the response is neutral or not. So from the output of Hugging Face model, I take only the value for label neutral, and I would call it response neutrality. Basically, that's it. Now let's run our evaluations and see the results. Now we expect to see two descriptors and statistics for two descriptors. This calculations takes a little bit more time because we load the models from Hugging Face for the first time, so let us wait until those models were loaded, and then we will be able to see the results. Here we go. We can see that now we have a little bit longer report. First part is Hugging Face Toxicity for response column. So again, there are some statistics and the visualization, right? So we can see that actually our responses are not toxic, like totally. And here is the second descriptor, response neutrality. And here we have some deviation, right? So please feel free to check out the visualization here. Well, I do like pre-built models a lot, but quite often we need to check very particular properties of our responses or questions. For instance, we might want to check consistency of the responses, and for doing that we might need to use LLM as a judge. That's a very interesting approach, and you can kind of write a prompt to validate your text and return you a score or category. Let us see how we can do it with help of Evidently. Basically, first of all, you would need to select what LLM you are going to use as LLM as a judge, and I'm going to use OpenAI. And, well, in order to use OpenAI, I would need to specify my environment API key, right? And there is very nice instructions on how we can do that. I prefer to do it through the environment variable, but you also can do it like this. Here is my prompt. So basically I tell LLM what is consistency and how it should score my responses, right? And here is the replace, where I'm going to have my text derived from the pandas data frame. Here is the prompt, and that's how I can build up the descriptor. Basically select the column name as usual, right? Now I specify the LLM I'm going to use as a judge. In my case, it's OpenAI prompting. So here is the prompt, right here. Also, I need to specify how I'm gonna call the string to replace, right? And I just selected replace, that's very default name, right? And my data from the pandas data frame will be replaced right there. Also, I need to specify what model I'm going to use, and in my case it's pretty simple, I would say, prompt, so I'm going to go for GPT 3.5 Turbo. Feature type is categorical, and I select display names, response, Conciseness. Here it is. In our case, I'm going to just calculate it over like 10 rows, and let's create the prompt. So yeah, I created it. Now we can run the report. Let's see how it looks like. So in this case, we sent the data to the GPT in order to get some response. So it's a little bit longer compared to the statistics which calculates in place. And it's ready. So we can see that all our responses are quite good, right? All 100% has label concise. Good to know. Cool. Quite often, together with scoring the text inputs and outputs, we can also analyze some metadata, because we might have, for instance, some upload, download, feedback from users to the response, or maybe some other metadata. We can also build up some statistic on top of this metadata with help of Evidently. Like, in my case, I'm building the report and I include metric column summary, so this is the basic statistics all calculated over the column. And instead of text data, I just selected column feedback. Let us see how it looks like. And well, it's pretty useful because you can see some statistics here, the share of the responses where we had no feedback, some upvotes 25 times and download 5 times. That's pretty interesting, and if you prefer to debug it and see when exactly you can then filter out your logs by this download and see what's going on there. Or maybe you prefer to do some checks, automated ones, and you can say, okay, I want to calculate the share of my downloads, and if it's higher than 10% or 1%, I would like to send an alert so that someone check out what's going on and fix it if the fix is needed, right? So it's also a very nice approach to check the quality of our assistant. Finally, quite often we might want to calculate some statistics over a couple of texts. For instance, we can calculate semantic similarity between the question and the response. It makes sense because it tells us how close semantically the response is to question, and it's a nice proxy metric to see whether the response is relevant or not. Let's calculate it. It's also very simple, so we go for the metric column summary metric, and now instead of the column name, we select semantic similarity descriptor. Let's select the display name, response question similarity, so that you can easily understand what statistic it is, especially if you include into your report quite a lot of statistics. In our case, we just browse statistics one by one, but generally you might want to include many metrics in a single report and browse it all together. So display name, response question similarity, which will be calculated over a couple of columns, response and question. And we specified here. So all the rest part is very similar. We run the calculations over the reference current data with mention of column mapping. Let's calculate it. Yep. And that's the result. So we can see that semantically our questions are quite close to responses, right? So the mean value is equal to 0.91. So this is very nice, and here is the distribution. Also, I suggest you to check out our tutorial on regression testing, where you can see much more details and information on how to choose the right descriptors and why actually semantic similarity makes so much sense. Well, that's it. That's how you can run different evaluations on top of your data, but quite often, as I mentioned before, you might want to dig deeper and figure out where exactly you get the specific value of one or another descriptor. For doing that, evidently support the datasets interface of your data, where all the calculated statistics are already included as the columns of your pandas data frame, and if you want, you can perform any indexing or selecting over this pandas data frame so that you can figure out what's going on with the data. Let us do that. I'm going to take dataset, the current one, and that's how it looks like. So let me open it up, and you can see that together with our original columns like question, response, start time, organization, etc., we also have one additional column, which is response question similarity. The exact column we calculated right there where we created our report. So now you can work with this column as with the standard column in a pandas data frame, so we can perform any indexing and selecting. So let me close it and go back to the example. So, well, if you prefer to do some ad hoc analysis, you can do it right there in Jupyter Notebook, but quite often you might want to not do some debugging, but rather to log data somewhere to database, for instance, or just share the report with our teammates who prefer to work with the browser instead of the Python, right? And there are quite a lot of ways how you can do that. For instance, you can create the JSON and send it to your Mongo database or the other database which work with the JSON data. So that's the JSON. Also, if you prefer to automate your Airflow workflow, right, and check the result for a particular metric and then decide what would be the next step based on this value, you can export the results as the Python dictionary, then derive any value by key and then write any condition you want. And finally, here is the HTML. Just call save_HTML method, specify the name, and let me open it up. Let us find it in sample notebooks. Yep, here is the report. If I open it up, I will be able to see the result in the browser, which is very handy specifically for some data analysts or product analysts, managers who prefer to work with the data but not work with the Python code, which makes total sense. At the very end of our tutorial, I also would like to shed some light on how you can build up monitoring dashboards over the time. It's quite handy in case you already deployed your LLM-based application to production and want to set up a proper monitoring. For doing that, let us define a combined report, which includes some statistics calculated over the text data and something calculated over the other categorical data, right? It's very easy because we already know how to work with the report. We just create one and then specify a list of metrics. I would include some metrics calculated over the response text, its sentiment of our response, length, and the indicator whether the response has some mentions of compensation. We already had this example before, right? That's text evaluations. And also I know that I have quite a lot of columns in metadata, so I have some feedback, region, organization, model ID, and environment. Why not to calculate some statistics over those columns, right? So that's my text evaluation report. Let me create this object, and now I can run my calculations. Let us see how this report looks like. First, I would need to run the calculations, that's it. But if previously we analyzed the results right here in Jupyter Notebook, now I would like to do something different. Remember, we created a project in Evidently Cloud. Here it is, very empty one. It's still here. Now let's add some data to the cloud project. Now, instead of just showing the report right there in Jupyter Notebook, I would use my cloud workspace, which I created at the very beginning. Now let me call method addReport and add this text evals report, which we just calculated before. You would also need to mention project ID, which you can derive directly from the cloud. Here it is, you can copy it from here, but I work with my Python Jupyter Notebook, right? And I still have the project object in memory, so if I just call the ID, it will return me the right project ID. So I'm lucky enough here. Let me run it. It's done, and now if we go to the Evidently Cloud and navigate to the reports, you will be able to see that now we have one report calculated here. Why not to view it? And we can see that we have all the calculated metrics there. It's sentiment for our response with all the statistics and visualization. It's text length for response, mention of some compensation, feedback, region, organization, statistics, and all the rest. So it's very similar to what you can browse in your Python environment, but now preloaded in the project, so that anyone you invited to the team and this particular project can load and see what is the results of your evaluations. And also you can download it from here and send to someone directly, which is also very nice. Cool. But our dashboard is still empty. Let us load some more data and see how we can build up a nice visual dashboard. I'm going back to my Jupyter. Now let me do the following. Let me simulate the batch usage of my virtual assistant. For instance, I can say, well, let me split my data into 50 rows of logs batches and calculate the report over each of this batch. So I will start from I already started from the first batch, first 50 rows. Here is my second 50 rows, third, fourth, and fifth. You can see that every time I calculate my report, I do not specify the report object again because it always stays the same, right? But I just pass new batches of data, so I rerun my calculations. And it might look like a spaghetti code, but I just decided to keep it like this for the simplicity. Of course, you can do it with help of cycle, right? Now let's see how it looks like. Go to our reports and we can see that, well, now we have quite a lot of reports here, so it's already make more sense. We can analyze every report and see the statistics calculated over different batches of data. Good. Very nice individual reports, but still no dashboard. Let's see how we can build up one. Let's navigate back to the project and you can see that this dashboard is still empty. Let us fix that. I would go for edit mode, add a tab, and then let me add something. For instance, descriptors tab. I hit submit. Here it is. And let me also add columns tab, because we also have some metadata here. Yep. I created 2 columns, and actually in my case it's not the real monitoring, right? Because I just simulated the monitoring by running my reports in order. So why not to hit this show in order so that I can see nicely pictures without any connections to the real time of the calculation. Yeah, now I can see just all the evaluations in order I added it to my project. Right? And here is the statistics for numerical data like sentiment and time, text length, mention of compensations. We can see the shares of true and false, right? That's all text descriptors we have here, and in columns we have quite a lot of information regarding metadata columns. Like this is the distribution for column organization. We have ACME external and just ACME, right? And you can see the shares in every report in a single dashboard, which is very nice. Also, we have some model ID distribution here. So in our last batch, we had only GPT 3.5 Turbo, right? Maybe it means something from the product view. And also some information about regions. We can analyze it as well. And environment, right? So that's how you can easily get a pre-built tab from Evidently. And also you can totally do it like manually by hitting Add Panel and selecting the type of your panel, the size, the metrics, etc., etc. But when it comes to myself, I would rather do it from Python. Now let's make it a little bit more interesting, and we have our extra topic, how to run conditional testing for LLM evaluations. That's quite useful and interesting because after you did some ad hoc analysis, you can already create some expectations on what is the target metric result, right? If you have these expectations, you can actually tell it to Evidently and instead of metrics, use some tests. Here you will get not only metric value, but also the results of comparison between the metric value and some threshold. For instance, I can create the following test suite. So now see, instead of report, I use test suite. Instead of metrics, I use tests, and I just check things like column value mean. I check whether the sentiment calculated over the response text column has mean value greater or equal to 0. This GT stands for greater than or equal. So I would like to see that my sentiment is not negative, right? Also, I can check the text length. The minimum value of the response should be like greater than 0 or equal, but it's more like check for technical errors, and some other statistics like max value for text length should be less or equal than 2000 symbols, and also some test for value mean. Okay, let's specify it. And in order to get some more statistics, I would like to create a cycle where I'm going to calculate these tests 5 times on 5 different batches of data. So that's my test suite, and I only run the evaluations 5 times. So I do not use any reference data. I have current batches of data, column mapping, and I specify the timestamp in order to simulate that I do these checks in an hourly basis, right? Let's do that. Yep. Here we go. And if I navigate to Evidently Cloud back, previously we checked reports, now let's check test suites. And you can see that, well, we have exactly 1, 2, 3, 4, 5 test suites here. Let us open up one. And, well, we see that there are 4 tests, 3 successful, 1 unsuccessful. I can even group it here by test status, then see only the failed, and check the details. Here we go. Finally, if you prefer to see the test results over time in the dashboard, like we just did for our metrics, we can specify the particular dashboard for our test results. We already play around with the UI, so now let's move back to the Python, and that's why we imported so many things from Evidently Dashboards UI, right? Again, if you already do not have a project object in your memory, you would need to figure out what is the project ID of your project. You can do it from the UI. So here is my project ID, but my Jupyter is still alive, so I can access my project from memory, right? The object is still here, and I'm going to access dashboard, use method add panel, and specify what panel I would like to add. In my case, I'm going to add dashboard panel test suite because it's the panel for tests actually. Here is the title, test results. No filter, just includes data from the test suites, not only reports, right? And here is the size, the panel type, and the time aggregation. I would like to create a new tab called tests and place my panel in this tests tab. And do not forget to save the updated configuration of your project. Let us run it. That's very, very fast because we just need to parse our test suites and build a panel. So if I go back to my project, I would need to refresh it. And now I can see the tests panel. Here it is. You can see that there are 5 columns, right? And here is the mean value, the only one failed test, so you can see what was the test. It's a test for mean value. It's expected to be greater than 500, but it's not, and that's the details, right? Column name is response, text length, and etc., etc. So this is a pretty nice thing. Well, I believe that's all I wanted to share with you. I hope it makes sense and helps you to understand how you can calculate some metrics and tests for your LLM-based applications, and maybe even set up the regression testing for your LLM-based application and automate the monitoring. Bye-bye!